The invisible reason your lungs would stop working before you even smelled the danger. And 2 lakes from here, in August 1986, it erased 1,800 people from the map before sunrise. Lake Kivu is breathing right now. 2 million people sleep on its shores. And nobody, not the geologists, not the volcanologists, not the engineers pumping gas from its belly, can tell you when it exhales for real. You're standing at the edge of the most dangerous body of water on Earth. Not because of currents, not because of what lives in it, because 300 cubic kilometers of carbon dioxide is sitting in the dark below your feet, pressurized by its own weight, held in place by nothing but cold water and fragile chemistry. That is enough gas to suffocate every person in Central Africa. And the lake is alive. It cycles. It shifts. Every few years, the water column moves, warm water rising, cold water sinking, and when it does, the gas moves with it. Scientists call it overturning. They study it. They model it. They cannot predict it. Here is what they do know. Lake Kivu sits directly on a volcanic rift. The East African rift is tearing the continent apart 1 centimeter at a time, and Kivu is sitting in the crack. Beneath the lake floor, magma heats the water. That heat dissolves carbon dioxide and methane from the volcanic rock, a slow IV drip that has been running for 10,000 years. The gas doesn't rise. It can't. The water pressure above keeps it dissolved, the same way pressure keeps carbonation locked inside a sealed bottle. But Kivu is not a bottle. It's a living system. The water stratifies into invisible layers, each a different temperature, salinity, and gas concentration, and those layers act like floors. As long as they hold, the gas stays buried. In 1986, at Lake Nyos in Cameroon, same geology, same mechanics, 2,000 times less gas. The floors didn't hold. 1,800 people were dead by morning. No warning, no earthquake, no eruption. The lake simply exhaled. A column of gas rose from the water, rolled down the hillside like cold fog, and replaced the air in every home, every field, every road within 25 kilometers. The carbon dioxide was invisible, odorless. It moved faster than anyone could run. Livestock died standing. People were found in their beds. One survivor said it felt like falling asleep, except she was the only one who woke up. Lake Kivu holds 2,000 times more gas than Lake Nyos did that night. And here is the part that should stop you. Nobody knows why it hasn't already done exactly what Nyos did. The lake breathes. That is not a metaphor. Researchers have documented periodic release events, pulses where deep water vents upward, where CO2 concentrations spike at the surface, where fish die overnight in blooms that local fishermen call ikira. The lake has a rhythm, but the rhythm is inconsistent. Some years it breathes easily. Other years the pressure climbs. In 2002, when Nyiragongo volcano erupted and sent lava directly into Kivu's northern basin, scientists braced. The heat should have destabilized the layers. The lake should have released. It didn't. Nobody knows why. That is not a reassuring mystery. That is a terrifying one, because it means the system doesn't behave the way the models predict, which means the models are wrong. And there is a second variable nobody has fully mapped, the methane. Methane is lighter than CO2. It rises faster, and Rwanda is currently extracting it commercially, a project called Kivu Watt, pulling gas from the deep water to power 200,000 homes. The engineers say extraction lowers the risk. They say removing gas reduces pressure in the deep layers, but extracting methane disturbs the stratification. It agitates the invisible floors that are keeping the carbon dioxide down, and some researchers have begun asking, very quietly, whether we are slowly unscrewing the cap. 2 million people live within the projected kill zone. Jaisni, Goma, Bukavu, cities built on the shoreline of a pressurized vessel that no one fully understands. Evacuation modeling for a Kivu limnic eruption exists. The results are not widely published. What is known is that the CO2 cloud would travel at ground level, following the terrain, the valleys, the roads, the exact routes that people would take to run. A significant eruption would not give 2 minutes of warning. The trigger could be almost anything. An earthquake, a larger volcanic event, a warm season shifting the thermal layers by just enough, or nothing identifiable at all, just the lake deciding that the floors have held long enough. Lake Kivu is breathing right now. The gas is down there, cycling, building, waiting. The engineers are pumping. The satellites are watching. 2 million people are asleep on the shore. And the one question the scientists cannot answer, the one that keeps the researchers awake, is whether Kivu's strange restraint in 2002, when the lava came and the lake still didn't blow, means it's stable, or whether it means the lake was simply not ready yet.